The Earth's unseen fury, the Cascadia time. Imagine the ground beneath your feet lurching, not for seconds, but for nearly 10 minutes. Buildings crumble, roads fracture, and a monstrous wave, tall as an 8-story building, races towards the coast, having crossed an entire ocean. This isn't a Hollywood blockbuster. It's a terrifying reality waiting to unfold along the Pacific Northwest. For over 300 years, immense pressure has been building deep within the Earth, setting the stage for a catastrophic event, one that will redefine disaster for an entire continent and impact millions of lives. The Cascadia Subduction Zone. A. Ticking time. Bomb. What if a hidden giant beneath our feet could reshape coastlines and trigger an unprecedented disaster? On January 26, 1700, a colossal earthquake, one of the most powerful ever recorded at magnitude 9, struck off the coast of the United States. This event, originating from the Cascadia Subduction Zone, unleashed a devastating tsunami that forever altered the coastline from southern British Columbia to northern California. Though sparsely populated at the time, clever research utilizing geological records, tree rings, and even historical accounts from Japan, which experienced a massive tsunami on the same day, allowed scientists to precisely pinpoint the date and cause of this ancient cataclysm. The Cascadia Subduction Zone, a 700-mile fault where the Juan de Fuca plate grinds beneath the North American plate, is a ticking time bomb. Pressure has been building for over 300 years since the last major event, and another big one is inevitable. Scientists estimate these magnitude 8.0 to 9.0 earthquakes occur every 200 to 1,000 years, meaning the Pacific Northwest is long overdue. When it hits, the impact will be catastrophic, affecting an estimated 15 million people across southern British Columbia, Washington, Oregon, and northern California. The immediate aftermath will be severe: widespread building collapses, cracked roads and runways, and destroyed bridges. Communication will be severed, and the worst part, a massive tsunami, could inundate parts of the Washington coast in as little as 10 minutes. This will be the worst disaster the US has ever faced, dwarfing the destruction of Hurricane Katrina or Superstorm Sandy. Eastern Washington, shielded by natural barriers like the Cascade Mountains, will largely escape the direct impact, but it will bear the brunt of the recovery effort. It will become the primary staging area, taking in refugees and coordinating the delivery of desperately needed supplies to the devastated western regions. Drawing parallels from other major earthquakes of similar magnitude: Chile, 1960, Alaska, 1964, Sumatra, 2004, and Japan, 2011. We know that the shaking can last anywhere from 6 to 10 minutes. Such proximity to Earth's surface amplifies their intensity, causing extensive damage. If the Cascadia earthquake and tsunami were to strike tomorrow, the human toll could be staggering. Over 13,800 fatalities and approximately 107,000 injuries. The economic fallout for Washington, Oregon, and California could exceed $70 billion. Understanding megathrust earthquakes. What force can unleash 1,000 times more energy than a typical earthquake? The Cascadia Subduction Zone is a vast fault line, stretching 620 miles and located about 93 miles offshore. It's where one tectonic plate slowly slides under another. The locked sections, approximately 18 miles deep or less, build immense pressure due to friction. When this pressure becomes unbearable, the plates slip, resulting in a colossal megathrust earthquake. These are the most powerful earthquakes, exceeding magnitude 9.0, releasing 1,000 times more energy than a 7.0 and 1,000,000 times more than a 5.0. Below the locked area, there's a zone where the plates move really slowly, just a few inches every few months. These slow slip events help to release some pressure, but also build up more pressure on the parts of the fault that are still stuck. This means that over time, it increases the chances of a huge earthquake happening. Geological records indicate that the part of the fault about 18 miles below the surface is completely locked, while deeper parts slide more smoothly. While the San Andreas Fault in California poses a significant threat, capable of generating a magnitude 6.7 big one with a 70% chance of occurring by 2030, the Cascadia Subduction Zone holds far greater destructive potential. A magnitude 9 earthquake from Cascadia would release 44 trillion pounds of dynamite, equivalent energy compared to a magnitude 6 quake's 44 million pounds. Unlike the San Andreas, a Cascadia rupture will trigger massive tsunamis, with waves potentially reaching 100 feet in some areas, wiping out coastlines and creating ghost forests from saltwater inundation. The geological record indicates that Cascadia megaquakes occur every 400 to 600 years, with the last one being over 300 years ago. This means we are within the projected window for the next major event. Our understanding of this zone is relatively new, discovered only in the 1970s when researchers, while studying the Ring of Fire, noticed the horror forest in Washington, its soil saturated with salt, indicating a past massive tsunami. Japan's historical records from 1700 provided the final piece of the puzzle, linking their tsunami to the Cascadia event. There's a 1 in 3 chance the next one will occur by 2050. Surviving the unthinkable, how do you prepare for a disaster unlike anything seen in generations? Survival during such an event hinges on preparedness. For those in the affected regions, particularly coastal areas, the immediate danger is the tsunami. After the initial shaking, seek the highest ground possible, taking only essentials like food and water. Do not return to lower ground after the first wave, as tsunamis often consist of multiple, increasingly powerful waves, as tragically demonstrated in Hawaii during the 1960 Chile earthquake. Basic earthquake survival involves following the drop, cover, and hold on protocol. Get low to the ground, hide under something stable like a table, and remain there until the shaking stops. After the initial impact, check for gas leaks. If you smell gas, do not turn on lights or do anything that might ignite it. The aftermath of a major Cascadia event will be chaotic. Aftershocks will follow, sometimes for months. Transportation will be a mess, with roads and airports shut down, and major routes like Interstate 5 likely having destroyed bridges. This will cut off food and water supplies, making it incredibly difficult for aid to enter or for people to escape. Gas pipelines will likely be damaged, and restoring them could take days inland to weeks or months along the coast. Power outages will be widespread within 100 miles of the coast throughout the entire Pacific Northwest, potentially lasting for months. Even telecommunications could be down for 2 to 3 months across the Pacific Northwest, Alaska, and parts of East Asia. The big one is not a question of if, but when. And when it comes, preparedness will be the key to survival. Earth's dynamic processes. Beyond the major quakes. What other unseen forces are shaping our planet? And what secrets do they hold? Our Earth is a vibrant, dynamic planet, constantly undergoing transformations far beyond the dramatic megathrust earthquakes. Consider the mysterious pockmarks discovered off the coast of Big Sur, California. These large, nearly perfect circular holes, some over 30 feet across and 15 feet deep, riddle the ocean floor. Discovered in 1999, these formations date back around 400,000 years, and their origin remains a mystery despite initial theories of gas venting proving false. In contrast, blue holes, like the Green Banana off Florida's Gulf Coast, are common underwater sinkholes that host diverse marine life due to their nutrient-rich environments. These are generally well understood and pose no threat. Beyond the dramatic, some earthquakes are silent. An earthquake in Indonesia, starting in 1829, famously lasted for 32 years, culminating in an 8.5 magnitude event in 1861. Researchers discovered this slow slip event by analysing coral that had been periodically exposed to open air. Meanwhile, the power of a single lightning bolt is astounding, heating the air to around 54,000 degrees C, causing it to expand rapidly and create the shockwave we know as thunder. Our planet is also a place of fascinating statistics. Close to 3 trillion trees, 70% water coverage, and 97% of its volcanoes lying underwater. Mauna Loa in Hawaii is the world's largest active volcano. its summit a staggering 11 miles from its base. Earth has experienced extreme temperatures, from a scorching 136 degrees in Libya to a chilling 129 degrees in Antarctica. Earth is the fifth largest planet in our solar system, and unique for having only one moon. The ground we walk on is constantly recycled through the planet's rock cycle, and even our moon experiences moonquakes caused by tidal stresses. Antarctica, despite its size, holds 70% of the planet's fresh water. Coral reefs, visible from space, are the largest living structures on Earth, hosting more species per area than rainforests. Earth's name comes from the German word for ground, and it's the only planet not named after a Greek or Roman deity. The Mariana Trench is the deepest point of the ocean, a staggering 7 miles below sea level. These diverse phenomena paint a picture of a planet alive with constant, powerful, and often unseen forces, unraveling Earth's mysteries, current discoveries, and future tech. What new frontiers are scientists exploring, from new atmospheric glows to planet-shaping discoveries? In 2018, the Western Indian Ocean off Madagascar witnessed the biggest active underwater eruption ever recorded. Over 11,000 earthquakes struck the small island of Mayotte, leading to the discovery of a new skyscraper-sized volcano, nearly 8,500 feet below sea level, fed by the deepest magma reservoir known, almost 34 miles underground. This activity confirms that Earth's mantle contains hunks of oceanic crust, like a peanut caramel filling, affecting magma flow and diamond formation. Scientists have even found that the mantle is very wet, potentially holding more water than all Earth's oceans combined, with tectonic plates dragging vast amounts of water into the Earth's interior, which can lubricate faults and increase earthquake likelihood. Deep beneath the ocean, incredible sceneries exist. Underwater waterfalls, lakes, and rivers formed by seawater dissolving salt layers. Canyons like the Bering Seas, with over 8,500 feet of vertical relief, dwarf their land-based counterparts. Despite crushing pressures, hydrothermal vents at tectonic plate edges release boiling hot water, supporting unique ecosystems. The ocean's vastness means most of our planet remains in darkness, as light waves penetrate only a few hundred feet. The loudest ocean sound ever recorded came from an icequake, picked up by sensors over 3,000 miles away. If all ice sheets and glaciers melted, global sea levels would rise by 260 feet. Moving to atmospheric wonders, skyquakes are mysterious, loud booms heard globally, often linked to earthquakes or cold weather, with various theories ranging from meteors to gas-escaping deep lakes. Fogbows, or white rainbows, form in thin fog. Thundersnow is a rare thunderstorm during a snowstorm with muffled thunder. Scientists have also identified Steve, a fast-moving stream of superhot gas, and Sam, its eastward-moving post-midnight counterpart, providing new insights into atmospheric phenomena. Diamond dust sees tiny ice crystals fall from a clear sky due to temperature inversion, while fall streak holes are circular gaps in clouds caused by planes. Fire tornadoes are terrifying spinning columns of flame and ash. Adding to Earth's mysteries are the vile vortices, 12 enigmatic points, including the Bermuda Triangle, linked to unexplained disappearances. These points notably align to form an icosahedron. Beyond Earth, astronomers have discovered 4 Earth-like planets orbiting Barnard's star, our second closest star system. These rocky planets are likely too hot for life, but are promising targets for future missions. Researchers are even studying how newly formed exoplanets might resemble Smarties, oblate spheroids, rather than spheres, supporting the disk instability model of rapid planet formation. The New Madrid earthquake, starting in 1811, is believed by some to still be producing aftershocks. Mount Yasur and Stromboli are volcanoes that have been continuously erupting for centuries. Ancient supervolcano eruptions in Rensselaer, now British Columbia and Alaska, influenced dinosaur growth. Australia's Burning Mountain hosts a coal seam, fire burning for millennia. Looking to the future, wireless electricity is being developed. utilizing magnetic fields to power devices remotely. Nikola Tesla envisioned global wireless power and modern power beaming technology, using microwaves and lasers, is being explored for drones, factories, and even beaming energy from space. Japan aims for a space solar power station by the 2030s. Japanese scientists are also working on converting sunlight and water into hydrogen fuel, a clean energy source. The Earth is a planet of immense power and constant transformation, from the slow, inexorable grind of tectonic plates to the sudden fury of a supervolcano. While the threat of the Cascadia Big One looms large, our growing understanding of these complex processes provides both a warning and a roadmap for resilience. By embracing scientific advancements, investing in preparedness, and continuously learning from our dynamic world, we can mitigate the impact of future disasters and adapt to the ever-changing face of our extraordinary planet. The future of our existence depends on our ability to respect and respond to the Earth's unseen fury.